Okay, welcome back to DET tutorial. In this video we'll be looking at ammonia. So if you're asked what is ammonia, what would you say? Ammonia is a hydride of nitrogen formed when an ammonium salt is heated with a non-volatile base. So the key word here is that ammonia is an hydride of nitrogen. It simply means that it is a combination of hydrogen and nitrogen. And how is it formed? It is formed when an ammonium salt is heated with a non-volatile base. This non-volatile base is usually a strong alkali. So this is the chemical formula of ammonia, NH3. Chemically, there are 3 atoms of hydrogen and 1 atom of nitrogen in ammonia. So this is the chemical formula of ammonia. Naturally, ammonia is produced when nitrogenous matter decay in the absence of air by the action of heat or by putrefying bacteria. So whenever nitrogenous substances or nitrogenous matter like plants, when they decay in the absence of air by the action of heat or by putrefying bacteria or by bacteria, the gas that will be released or the gas that will be produced is ammonia. So this is a very important fact, as it can come in an exam, that which of the following gas will be released when nitrogenous matter decay in the absence of air by the action of heat or by putrefying bacteria. Just know that the gas that will be released is ammonia. So having known this, let's look at the laboratory preparation of this gas, ammonia. So in the lab, ammonia is prepared by heating a mixture of powdered ammonium salt and a strong alkali. So it is prepared by heating a mixture of powdered ammonium salt and a strong alkali. From the previous page, we've already established that ammonia is a hydride of nitrogen. How is it formed? It is formed when an ammonium salt is heated with a non-volatile base, and I've said that the non-volatile base is usually a strong alkali. So in the lab, ammonia is prepared by heating a mixture of powdered ammonium salt and a strong alkali. So the ammonium salt that is usually used is ammonium chloride. So when the powdered form of ammonium chloride is heated with calcium hydroxide, calcium chloride will be formed, ammonia will be formed, which is the compound of interest, and water will also be formed. So this chemical equation is high yield and is very important. You can be asked in an exam that when a powdered mixture of ammonium chloride and calcium hydroxide is heated, which of the following gas will be released? The gas that will be released is ammonia. And you should know the other substances that will accompany it. The calcium chloride will be produced and water will also be produced. This is a setup for the laboratory preparation of ammonia. So we have a powdered mixture of ammonium chloride and calcium hydroxide. So when these two mixtures are heated, they react to form ammonia, and the ammonia that is formed will then move up, will be collected by upward delivery. So this is the ammonia that is produced. It is collected by upward delivery, and the reason ammonia gas is collected by upward delivery is because it is lighter than air. So this is very important too. Why is ammonia collected by upward delivery? It is collected by upward delivery because it is lighter than air. So when the powdered mixture of ammonium chloride and calcium hydroxide is heated, from the previous page we said that there are 3 substances that will be formed. Calcium chloride will be formed, ammonia will be formed, then water will also be formed. So The water is usually in form of vapor gas. The ammonia is a gas, while the calcium chloride is solid. So once these substances are produced here, the ammonia and the water will move down into this part of the setup, and the ammonia will then move upward. It will move upward. The reason why it will move upward is because it is lighter than air. So air will come down while ammonia will go up. So as it passes through this part of the setup where we have calcium oxide, also known as quicklime, it will dry the ammonia. So the function of this calcium hydroxide is to dry the ammonia, and then the ammonia is collected by upward delivery. We have the dry ammonia here collected by upward delivery, and I've said that the reason why ammonia is collected by upward delivery is because it is lighter than air. So the ammonia that is produced here will rise up the setup due to its lower density compared to the surrounding air. And usually substances or gases that are lighter than air are usually collected by an inverted container. So you can see that this container is inverted. This is the top of the container and this is the bottom. So gases that are collected by upward delivery, they are usually collected by an inverted container, and that is because they are lighter than air. So in the laboratory, ammonia is generally prepared by heating a mixture of powdered ammonium salt and a strong alkali. So the ammonium salt Ka is usually ammonium chloride, but another ammonium salt that we can also use is ammonium tetraoxosulfate 6. So a mixture of powdered ammonium tetraoxosulfate 6 and calcium hydroxide, which is a strong alkali, when they are heated, calcium tetraoxosulfate 6 will be formed, ammonia will be formed, which is a compound of interest, and water. So when you use ammonium, the other salt that you can use is ammonium chloride. So when you heat a powdered ammonium chloride and this strong alkali, calcium hydroxide, the substance that will be formed will be calcium chloride, ammonia, and water. So the difference between these two is that when ammonium tetraoxosulfate 6 is used, calcium tetraoxosulfate 6 will be formed, and when ammonium chloride is used, calcium chloride will be formed. So this is how ammonia is prepared in the lab. You can either use ammonium tetraoxosulfate 6 or ammonium chloride. So there are different forms of strong alkali that we have. Calcium hydroxide is a strong alkali, sodium hydroxide is a strong alkali, potassium hydroxide is a strong alkali, and barium hydroxide is a strong alkali. But in the laboratory preparation of ammonia, calcium hydroxide is preferred, and the reason why it is preferred is because of two main reasons. Number one, because the compound is very cheap. So calcium hydroxide is preferred in the laboratory preparation of ammonia because it is very cheap. Then the second reason why it is preferred chemically is because it is not deliquescent. And what is a deliquescent compound? A deliquescent compound is a substance that has strong affinity for water vapor from the surrounding environment and eventually dissolves in it. So the reason why calcium hydroxide is preferred is because it is not deliquescent. It is not a substance that has strong affinity for water that will absorb it then dissolve in it. These are examples of deliquescent substance: calcium chloride, potassium hydroxide, sodium hydroxide, lithium hydroxide, magnesium chloride, zinc chloride. All these substances are deliquescent substances. And why are they deliquescent? Because they have strong affinity for water vapor from the surrounding environment, and they eventually dissolve in them. So if you use for example sodium hydroxide will absorb water from its environment and dissolve in it, and so you can no longer use it for the preparation of ammonia. So the two main reasons why calcium hydroxide is preferred is because it is cheap, and secondly, it is not deliquescent. Calcium hydroxide will not absorb water to dissolve in it. It will not absorb water from the surrounding environment and dissolve in it. That is why it is preferred in the laboratory preparation of ammonia. This guy will absorb water. It will absorb water and dissolve in it. Same thing with potassium hydroxide, and same thing with barium hydroxide. They will dissolve water, they will absorb water and dissolve in them, but calcium hydroxide will not absorb water, and that is why it is not deliquescent, and that is the reason why it is preferred in the laboratory preparation of ammonia. So in the lab, ammonia is prepared when a mixture of powdered ammonium chloride and calcium hydroxide is heated. So when these two substances are heated, ammonia is liberated. So this ammonia that is formed, which is the compound of interest, it can be dried by passing it through calcium oxide, also known as quicklime. From our previous setup, we have this setup for the production of ammonia. So the ammonia that is produced, like I said, is collected by upward delivery, and the reason for that is because it is lighter than air. So the ammonia, as it moves up to be delivered by upward delivery, it passes through a part where we have calcium oxide, also known as quicklime. So the function of this calcium oxide, which is also called quicklime, is to dry the gas, is to dry ammonia. So that is why we have dry ammonia here. So the function of calcium oxide, also known as quicklime, is to dry the ammonia. So the ammonia is dried by passing it through calcium oxide. And one more important thing that you should know here is that there are other drying agents. In chemistry, the usual drying agents that we have, like tetrasulfuric acid and calcium chloride, they cannot be used in drying ammonia, and the reason is because they react with ammonia. So it can come as a question that which of the following substances can be used in drying ammonia. Just to know that it is calcium oxide. And also it can also come as a question that why is it that tetrasulfuric acid and calcium chloride, which are usual drying agents in chemistry, why are they not used, or why can they not be used in drying ammonia? They cannot be used in drying ammonia because they react with the gas, which is they react with ammonia. So that is the reason you cannot use tetrasulfuric acid, and that is also the reason you cannot use calcium chloride. So with this, we are done with today's tutorial. In the next video, we will look at the industrial preparation of ammonia.